All right, today's lesson. It's the ninth lesson of the school year, believe it or not. Wow, time's flying fast. We are learning about sequences. There's two words, arithmetic and geometric. Some of y'all have already seen these on your Delta Math because there were some problems I just picked. I explained them as we went. Today, we're focusing on that lesson. So take this word right here, underline it on your paper, would you? Arithmetic and geometric. You're going to learn arithmetic is when we are changing by adding, or it'll, as a picture, it'll look like a line of dots. Whereas geometric, so I'll go ahead and put that in the packet. It looks like a line of dots, or it means we're changing by adding or subtracting. So I'll do add, subtract. Geometric is when we multiply or divide, and what that'll do is it'll make the dots look like they're curving. So go ahead and add that. It'll look like it's curving, and that's when you multiply or divide. And that's what we're focusing on today, sequences that are either arithmetic or geometric. Okay, so all this stuff we're going to go through as we continue on, but that in a nutshell, that's what we're learning about today, these two types of sequences. They're patterns, just like the bell ringer, it's following patterns, okay? So beginning here, when we talk about a sequence, you will hear me say first term, second term, third term, fourth term. What I'm talking about is I'm not looking for the number one. It just, when I say first term, I mean literally the first number you see. So just to be clear, when I say first term, do I mean the number one? No, what would I mean in this sequence? Which is a 3. The first term would be 3. The symbols you would see is this. They do an A with a little 1. That would be the first term. That's how they're going to write it. The second term, this is arithmetic. That's why I'm doing an A. I know it's arithmetic because what's the pattern here? 3, 5, 7, 9. What's the pattern? What with 2? Multiplied by 2 or add by 2? Add. Because I'm adding, I'm going to go back to the previous slide. Because I'm adding, this is an arithmetic sequence. So that's why I'm using the letter A. So A1 would be 3. That means it's arithmetic. What would A2 be? 5. You're catching on really quick. What about A3? And though they did give us A4. Sorry, what's A4? Though they did not give us A5, I bet you could predict the pattern. What would A5 be? A5 would be 11. Good, and so on. The dots mean it goes on forever. You could keep coming up with more. They follow that pattern. So a sequence in general, what is a sequence? A sequence is an ordered pair or an ordered list. I shouldn't say pair. I'm sorry. Ordered list of numbers. It could be infinite or finite is how you say that. This one right here is infinite. Do you write that down? Infinite means it has those 3 dots. What do the 3 dots mean? It goes on forever. Just continues on. The second one is finite. Finite means it has a stopping spot. This last one is finite. It's a weird word, finite. That means it has a stopping point. On this one, there's no dot, dot, dot. What is the last term of this sequence? What is the very last one? 80, and it stops at 80. Okay, so that's those words as they come up, infinite and finite. So we're first going to look at arithmetic sequences. Okay, arithmetic sequence. Here's a definition for you. If each successive term in a sequence has a common difference, is the word, common difference. If they have a common difference, which you could also call a constant rate of change, like a slope, the sequence is called arithmetic. Because a rate of change is like a slope, these will look like lines, as I was telling you before. The sequence is called arithmetic. The nth term of the arithmetic sequence is given by this formula. AN equals, put the letter D, parentheses, N minus 1 plus A1. Now, that's the simplified version, and that's like the one that looks the neatest. But if we did a little math, you could rewrite this formula, and I think this is the way you'll actually like it better. If you did a little math, what are you supposed to do when you have a letter in front of a parentheses? What does a parentheses mean to do mathematically? Multiply. I'm going to go ahead and multiply this out. You would have d times n. I'm going to go ahead. I'll just leave it as dn, d times n. I'm going to change the order, do plus a1 minus d. I think this formula is going to be easier for you to work with today. So you might be looking at it right now going, I don't know what is what. Yep, but n is going to be like our variable. It's like x. You don't actually multiply it, you just put the number in front of it. It'll be like some number. So on a previous problem, you know how I was changing the 2? 2 would be the common difference. You would just write 2n plus whatever the first term was. Was it a 3? 3 minus 2, which would be 1. That's what it would come to. Okay, so now, what is what? An is what we call the nth term. What does that mean? It means it could be the 5th term, the 6th term, the 7th term, the 8th term, the 9th term, whatever you need it to be. An can be whatever you need it to be. Just a little bit. Okay? The letter D is the common difference, and A1 is your first term. Now, if you're not as good at catching on to patterns, the way to find your common difference is you can subtract one term by the previous term. You take any two terms that are back to back and you subtract. You take the second one and you subtract the first one. Okay? When you do that, you'll get your common difference. Now, a lot of us, though, are going to see the pattern. You won't actually have to do this part of the math right here. You'll just see it. Okay, let's look at examples 1 through 4. And see if we can come up with them. On this slide, we have examples 1 and 2. So it says this: determine the common difference and the next 3 terms in each arithmetic sequence. Then write the equation to find the nth term of the sequence. Okay, here it is. It says 8, 14, 20, 26, blank, blank, blank. 8, 14, 20, 26. Do we know the pattern? Does anybody see what the pattern is? Add 6. Good. Now, if you did not know, you could pick any 2 numbers and subtract them. Any 2. So, Carla, just which 2 do you want to use to subtract? You want to use 20 and 26? Okay. If you did not know, you take any 2 terms. It doesn't matter, any 2. I'm just going to pick 26 and 20. You subtract the second by the first. What is 26 minus 20? 6. That's the way you know how much it's changing by. You can take any 2. You would have got 6 all throughout. I just did 20 and 26 because they're the same tens. I thought it'd be easier to subtract. So if it changes by 6, if this is 26, what goes next? 32, Jose, I love it. 32. Good. All right, sorry, I don't remember what I said right there before break. We have 32 here. What's the next number? When you add 6 more, what do we get? 38. And it asks us to find 3 terms. So that's this, the first, the second, and I should say the first. This is technically 1, 2, 3, 4. That's the 5th term, 6th term. What's the 7th term going to be? 44. Okay. At the end of today, what you're going to be responsible for is how to write an equation. So now I'm glad you see how the pattern works. You're going to have to write an equation. So here's the formula that I suggest you use. We're going to write AN equals D times N plus A1 minus D. And if it's easier, you can put this in parentheses. This part will simplify, but I'm going to leave it like that so we're not so confused. So here's how our answer would look. You write AN. That's kind of like y equals. AN on a sequence, you just do AN. That's kind of like your y equals that we normally have. Now, what did we say our common difference was on this problem? 6. So it'll be 6n. You don't touch the n. You leave that alone. That's kind of like your x. Plus, what is a1? 8 minus, what's d one more time? 6. The last 2 terms will always simplify. These 2 will always simplify together. What is a minus 6? 8 minus 6 is 2. There's our formula right there. That's what we call the nth term formula. It's a really weird thing, but it just means if you need to find any particular term, you can plug in a number, you'll get it. I'll show you. I'll prove it to you. You ready? Listen, 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 listen. Look up here. What's the fifth term? When you look up here, what's the fifth term? 32. Perfect. The fifth term is 32. So here's how the formula works. If this is the fifth term, that would be A5 equals 32. Here's what that means. On this formula we just solved, if you plug in a 5 for fifth term, you would get 32. What's 6 times 5?
30.
If you plugged in a 5 here, 6 times 5 is 30. When you add 2, what do you get? See how it works? Does that make sense what we're actually finding? That's what they call the nth term. That's what it means. You can find any term you want now just by plugging in a number, and it'll give you the value. Does that make sense to you? So if we wrote out all these sequences to find the 100th term, do we actually have to write them all out to find 100? No, you can just plug in 100 right there, and it would be 6 times 100 plus 2. That's what you should get if you wrote out 100 of them. Make sense? Okay, let's go to the next one. Good morning. The next one, we have negative. Thank you. Good to have you today. We have negative 24, followed by negative 14, negative 4. Have y'all figured out what's happening? What are they doing every time? Okay, now this is tricky. I want to do a little number line here. If you had a number line, and this is 0, whoops. If this is 0 over here, where's negative 24? You can sit right here. Way over on the left. There's negative 24. Then negative 14. There's negative 4. Here's 6. Okay, which way are we actually moving? Are we getting bigger or smaller? We're getting bigger each time. How much am I changing by each time? Whoops, I need to go from 4 to 6. How much am I changing by every time? Think about these two. 10, good, you're adding 10 each time. We are adding 10 each time. So that's called your common difference. Your common difference is 10. Remember, you can always take any term and subtract the previous one. You could have taken, say, 6. Said your difference would be 6 minus the previous term, which would be negative 4. What happens when you have a minus and a negative back to back? Becomes positive. What's 6 plus 4? 6 plus 4 is 10. Yeah, that's another way of getting it. So we add by 10 each time. So if this is a 6, what comes next? Okay, Leah's great. I want to make sure someone else now knows. If this is a 16, what comes after that? Anybody but Leah? 26. Anybody but Leah and Julia? 36. Good. Okay, now I want you to notice this time in just a dot. This time was a 3 dots. For those that just came in, tell Gustavo, what does this 3 dots mean? Yeah, what does that mean if you see 3 dots? It goes on forever and forever. And if you just have one period, it just stops. That would be finite. That's infinite. Okay, so now let's write an equation. Remember, here's the equation I gave you on the previous slide. I said AN equals DN plus A1 minus D. That's the formula you're going to use, where these two numbers will always simplify together. So let's plug in our values. On our problem, what is the letter D? 10. So you'll say 10N plus, what's our very first term? A negative 24 minus, what's our D? 10. Okay. Here I have a negative 24 minus 10 more. Does anybody know what happens? What happens with the plus and a negative back to back? No, that's 2 negatives. This is a plus and a negative. It stays negative, so I'm going to cancel that out. We have a negative 24 minus 10 more. A negative 24 minus 10 more is, think over here, a negative 24, but minus 10 more. Where would I be? Negative 34. That's your formula this time. So again, you could find any term just by plugging into n. So if I wanted the 10th term, you plug in a 10 there. You'd have 10 times 10 minus 34, and that's how you get the 10th term. Cool? Okay, I want to show you two more before I expect you to be able to try it, okay? On the next slide, we're going to look at examples 3 and 4. So here's examples 3 and 4 on the next slide here. We have negative 101, negative 112, negative 123, negative 134. Does anybody see the pattern? Can anybody predict what's going to be next? $135 or one? Nope. You were closer with the 5. Negative 1, not 35. 45. Here, look at the pattern. 101, 01, 112, 12, 123, the 23. So 01, 12, 23, 34, 45. What's going next? Negative 1, then what two numbers? 56, 56. That was a 4, 5. That's a 4, 3, 4, 2, 3, 1, 2, 01. Okay, what's the last one going to be? Negative 1, 6, 7. What's the dot mean? Stops. Okay, good. That, you see the pattern now? Okay, on our common difference, this time I'm going to just use the formula. To find our common difference, you take any two numbers, you subtract one from the other. You take the second and subtract the first. Which two numbers you want to choose here? Okay, we want to use these two numbers. If I want to find my common difference, you take the second number and you subtract the first number. That's how you do it. You take the second number and you subtract the first number. You can choose any two, but you always do that. Say with me, Moxie, please. So what do I do with a minus and a negative back to back? It becomes a positive. So it's negative 112 plus 101. Anybody good in mental math? Ooh, not quite, because it was a negative then a positive. 11's your number. That's right. It's negative 11. Sorry, my board just went out. It's negative 11. That's the number. So now let's use our formula. Without me telling you, you tell me, what's the formula? Like just the symbols? dn plus the first term a1 minus d. Perfect. Let's plug in our values. You never plug in for an. I do plug in for d. What's d? Negative 11. What's a1? Negative 101 minus, what's our d? A negative 11. Okay, I gotta adjust this. I have a plus next to a negative. What do you do with a plus next to a negative? Negative. What about a negative and a negative? Those become positives. Okay, the last two terms will always simplify. So we have negative 11n, negative 101 plus 11. That's going to be negative 90. That's what that would be, negative 90. We don't have our computers open right now, so I'll just give you that calculation. That would be a negative 90. All right, last one. Last one here. We have a 3.8, a 5.1, a 6.4, a 7.7. Oh my goodness. Without me telling you, does anybody see the pattern? Yeah. Pico thinks he knows it. Anybody else? 3.8, 5.1, 6.4, 7.7. So Kiko's got it. What's the next number, Kiko? 9. And since it's 9, you can write just a 9. I'm going to go ahead and put 9.0. Board's freezing on me again. I don't know what's going on with it today. I'm going to put 9.0. Okay, anybody else pick up the pattern yet? Okay, if you're not sure, take any number and subtract the one that came before it. Which two terms, Moxie, I'll let you pick. You pick any two. It doesn't matter which two you pick. They just have to be next to each other. Which two do you want to use? Okay, if we're using those two, you take the second number and you subtract the first one. 7.4 minus, 7.7 minus 6.4. Ariana, do you know what that is off the top of your head? 7.7 minus 6.4? How about let's do the decimals. What's 0.7 minus 0.4? 7 minus 4 is
3.
7 minus 4 is 3. What about 7 minus 6? 1. So what we're doing is we're changing by 1.3 every time. Changing by 1.3. So 3.8, 5.1, 6.4, 7.7, 9.0. What comes next?
No.
10 point. Go with it. 3. That's right. I can see it on the top of your tongue. It's 10.3. That's good. All right, 10.3. And Carlo, what would our last one be? 11.6. Good math. And last time for me to ask this question, what does it mean when you see the dot, dot, dot? It goes on forever. Whereas if you just have a dot, that means it's literally stopping. That's the last one. All right, let's write an equation. My formula, it's already written right there. AN equals DN plus A1 minus D. Okay, let's plug in. Gustavo, what's our D on this problem? Our D is how much it's changing by. So the 9 would be called A1, 2, 3, 4. This would be A5. That's what you would call that, is A5, because it's the fifth term. It's the fifth in the row. But what our D is how much it's changing by. We're changing by 1.3. So put 1.3 in plus, what's A1? 3.8 is our A1. 3.8. And then we subtract D. What is D again? 1.3. Remember, when you write this formula, the last two numbers will always simplify together. If you don't do that, you won't get credit on your delta math here in a second. What is 3.8 minus 1.3? What's the 0.8 minus the 0.3? 0.8 minus the 0.3. See the bigger, it's going to be, oh, not 1.5, but what's 3 minus 1? 2. So it'll be 2.5. That'll be 2.5. That's our equation right there. So you've answered this question a few times. Why do some of the sequences end with dot, 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 and others without the dot, dot, dot? And the difference is, what are the dot, dot, dot means what? Sequence goes on forever. I'll put it in parentheses, it's infinite. So if you just have a period, though, that would mean it does not go forever. It stops. Okay, you've seen me do 4. You ready to try one? Let's try one. You try DOL number 1. Pause here. Now let's take a look at geometric. So if each successive term in a sequence has the first 2 blanks are called common ratio. So it was a common difference for arithmetic. For geometric, we call it a common ratio. If each has a common ratio, which means a proportional change, this sequence is called geometric. This means it's multiplying. Multiplying. The nth term is given by, now notice I have a G. What do you think G stands for? No. Geometric. Geometric. The formula looks like this. A1 times in parentheses means multiply, A1 times your ratio to the power of n minus 1. Now this formula, at first, to me anyways, looks a little trickier, but it's actually easier because you don't have to simplify anything. We'll just plug in and the formula will be done. Okay? So Gn is the nth term. This serves as kind of like your y. That's kind of like your y. A1 is the first term, and R is the common ratio. Your n is kind of like x. Your independent variable.
Oh, I hope that's one with a comma.
Oh, in the formula?
Yeah.
No, it's A1. Oh, I put A1. I'm sorry. That's a mistake. A would mean arithmetic. We're not doing arithmetic. What are we doing? Geometric. Change that to a G. These two G1s. Sorry. G1. G1. My bad. G1 and G1 for the first term, the first geometric term. Okay, so just like arithmetic, we're going to look at 4 examples. If you can't readily see your ratio, what you do is you take any 2 terms and you divide the second one by the first one. So remember common difference? If you couldn't see the pattern, you would subtract the second by the first. On this, you would divide the second by the first. You pick any 2 terms that are back to back. Okay, so let's take a look at 4 different examples. First one, example 5. Here's our pattern: 8, 16, 32, 64. Can anybody see what's happening? Am I adding by 8 every time? Nope, not adding by 8 every time. That would be 8, 16, 24, 32, 40, 48, 56, 64. Ah, this one's different. We're not adding at all. What are we doing instead? We're multiplying. How much are we multiplying by? 2. Yeah, your R is 2 here. Now, if you did not know that, the way you find it is you take any 2 terms. Are you okay if I choose 8 and 16? If I chose 8 and 16, what you do is you take the second number and you divide it by the first. What is 16 divided by 8? 16 divided by 8 is 2. And that's what it's telling you. You're multiplying by 2 every time. So does anybody know what 64 times 2 is? What's 2 times the 4? Let's start there. I'm breaking this down. 8. So 8 will be your last number. What's 2 times the 6? 12. So the number is 128. Good. Jose, stay with me. Don't lose me here. Does anybody know what 128 times 2 will be? What's 2 times the 8? 16. That's a 6. You're going to carry a 1. 2 times 2 is 4. We carried a 1, so it's now a 5. And then what's 2 times 1? 2 times 1 is, you're correct, 2. I wrote it wrong. Okay, last one. 256 times 2. 256 times 2. Hey, Valentine, close your computer so it doesn't distract. What's 2 times the 6? 12. So you get last number's a 2. We're going to carry a 1. What's 2 times the 5? 10. We carry the 1. It's now 11. We carry the 1. What's 2 times 2? 4. You carried a 1, so it's now 5. 512 is our last number. Now, notice these numbers are getting big in a hurry. Geometric, it's either big in a hurry or small in a hurry. That's what always happens. So, how does the equation look? I told you in the previous slide what's nice about these. Whoops, I did an A again. It's a G. What's nice is you do not have to simplify anything. You just plug into the formula and you're done. So, let's plug in. Gn is kind of like your Y. You don't do anything with Gn. I do something with G1. What is G1 in this problem? What is my very first term? 8. What is my R, my ratio, my common ratio? 2. N is kind of like your X. You don't touch your N. That's your formula right there. You do not have to simplify. That's what's nice about geometric. It's a little bit harder sometimes getting the numbers because they get so big or so small so fast. But the formula is easier to work with. That's an easier formula. Oops. Okay, so example 2. I'm going to roll Let's see this one. Negative 24, negative 12, negative 6, negative 3. Does anybody see what's happening every time? Jose? See your brain working. Negative 24, negative 12, negative 6, negative 3. Can anybody see the pattern? Nope, it's not adding by 12. It's not subtracting either.
Division?
It is division. What's happening each time?
Getting smaller.
Hey, get some eyes up here. What's happening? It is getting smaller. It is being divided. What's it being divided by? Can y'all see yet? Look at the smaller numbers. Sometimes it's easier to look at the smaller numbers. From negative 12 to negative 6 to negative 3. It's getting cut in half every time. Do you see how it's getting cut in half every time?
Fourth.
So it's getting cut in half every time. So let's just say you're doing your work and you can't see it yourself. Here's what you would do. You take any two terms. I suggest taking smaller numbers. So take any two numbers. Which two should we use? The negative 6 and the negative 3. You do the second term on top, and you divide by the first term, which in this case would be negative 6 divided by, negative 3 divided by negative 6. I suggest on geometric, always take your two smallest values. So up here, my smallest were 8 and 16. Here, it's negative 6 and negative 3. I use the two smallest. What happens with back-to-back not back-to-back negatives, when you take a negative and divide by a negative? They become positive. And what is 3 divided by 6? Well, that reduces. It's a fraction. What number goes into both 3 and 6? Nope, 2 doesn't go into both. 3 does. 3 goes into 3. 1 time, 3 goes into 6. 2 times. Which means every time it gets multiplied by half, it gets divided by 2. So the next one, I'm going to write it as a fraction. If you take negative 3 and you multiply it by half, what you do is this. You take negative 3 and you multiply it times 1. What's negative 3 times 1? Say it with me. Negative 3 times 1. Negative 3. And then you divide it by 2. Well, 2 doesn't go into 3, so we leave it like that. So the next one would be negative 3 halves. The next one after that, what you do is you take negative 3 halves and you multiply it times 1 half. So it's negative 3 times the 1. What's negative 3 times the 1? Negative 3. And then it's 2 times the 2. 4. And we do it again. We take the negative 3 and times it by the 1. What's negative 3 times 1? Negative 3. And then you take the 4 and you times it by 2. Not 6, but 8. 4 times 2 is 8. And that's how you come up with your pattern. Now, the easiest part of this is we plug into this formula right here. We're going to plug into this exact same formula. I'm just going to copy and paste it. We're going to plug into that formula right here. So our equation would look like Gn equals, what's G1? Negative 24. What did we determine our common ratio was? I put a D out there. That's wrong. It's not a D, it's a R. What's our common ratio? 1/2. I'm sorry about that. That's an R there, not a D. It should be an R. And you don't know N. I mean, you don't change N. N is like your X. You leave it like that. That's your equation right there. Okay, I'm going to do 2 more, and then we'll call it. Okay, example 7 and 8. Well, I'll have to show you pictures. I forgot. Sorry. 7 and 8. Let's see example 7. What's the pattern here? I have 5, then a negative 25, then a positive 125, then a negative 625. What's happening with the positives and negatives? What's happening with the positives and the negatives? They're mixed. So it's going positive, negative, positive, negative. What's the next one to be? Positive and then negative. So this will be a negative. I'll go ahead and put the negative there. This would be Positive. Do y'all know what this one's being multiplied? Do y'all know what number it is multiplying by? 5. Now, if you know that, if it's switching between positives and negatives, that's when it's a negative number. So this ratio is -5. How you could get that, again, if you take the smallest two numbers, take the smallest, the second number and divide it by the first, and the value is -5. So this one's just getting too big. I'm gonna have to type those in the calculator. Desmos star. I'm going to type this in real quick. -625 times 5. I'm going to see what I get. I think it's 3125, but I'm not for sure. 625 times -5. Yes, 3125. So we have 3125. Notice with geometric, the numbers get either really big fast or really small fast. And then I'm going to times this by another -5. -15,625. Oh my goodness. -15,625. And then my last one, 78,125. Wow. It's like my bank account. I wish. 78,125 is our last term. And why can I say last term? Not 1, 2, 3, 4, 5, 6, 7. It is the seventh term, but why could I also call this the very last term? How do I know it's the very last one? There's no ... It's just a period. Perfect. Okay, our formula. Remember, it's Gn equals G1 parentheses R to the power of n minus 1. On our problem, what is G1? 5. What is R? -5 to the power of n minus 1. There's your equation right there. Okay, I got to make sure you have it down. So let's walk through it. This last one, I intentionally picked a weird number. If you can't see what the pattern is, if you cannot see the pattern, how do you come up with the common ratio? Oh, that's what we did for arithmetic. How do you do geometric? You don't subtract for geometric. You divide. Which two numbers should we choose? The smallest, what I would suggest. Let's take 1.1 and you divide it by 1. Now this you probably know off the top of your head. What's 1.1 divided by 1? Not 1, but 1.1 divided by 1 is 1.1. So that's what we multiply by every time. So I'm going to start with this 1.331 and we'll multiply. Let's see what we get. 1.331 times 1.1. I get 1.4641. 1.4641. 1.4641. Goodness, I'm already forgetting. 1.4641. Good. And then we times it by 1.1 again. 1.61051. 1.61051. 1.61051. 1.61051. And I do it one more time. Whoops. Times 1.1. 1.771561. Goodness gracious. I went way too crazy. 1.771561. 1.771561, I think. 771561. Yes, that's it. Now that's the hard part on geometric. Is the numbers either get really big or really small fast. That's the hard part. But the easy part is writing the equation. For geometric, you just plug it in. We just plug in our numbers. You don't have to simplify. Simplify makes it very easy. So on our problem, what is G1? 1. What is our R? 1.1. to the power of n minus 1. There's your equation just like that. So I gave you on my example, some very tricky ones. Honestly, they're trickier than what you're going to see. I teach pre-cal, and I just came up with some tricky ones that I just pulled what I usually show them, which is at like senior level class. Yours are going to be easier. Yours are going to look more like your DOL. So on the next slide, we have our second DOL. I want you to take a look at this one. This one's a much easier problem to figure out. DOL number 2. All right, to finish this up, I want to make sure you see what it looks like as a graph. Look over here. Notice, is this graph continuous or discrete? Discrete. A discrete graph comes from a sequence. So if it's discrete, since the graph is discrete, it is represented by a sequence. Now, we've learned about 2 sequences today. What 2 sequences have we learned about today? What are the 2 names of them? One starts with an A, one starts with a G. Arithmetic and geometric. Okay, now, how do you know which one it is? When you look at the picture, does it look like a line or a curve? Hey, I need everybody looking. Does it look like a line or a curve? A line. Arithmetic looks linear. Arithmetic looks linear, and so you would say it's an arithmetic sequence since the points follow a linear pattern. If it looks like a line, it's arithmetic. If it curves, it's geometric. Y'all got that?
Yep.
If the points look like a line, it is arithmetic. If they look like a curve, it's geometric. So if we were going to find the equation, arithmetic, I don't want you to forget this. Arithmetic's equation is AN equals, DN plus A1, A1 minus D. That was our equation for arithmetic. And so in this problem, how much am I changing by? If I go from 4 to 3.5, and from 3.5 to 3, and from 3 to 2.5, and from 2.5 to 2, and from 2 to 1.5, and 1.5 to 1, how much am I changing by?
1.
Not 1 whole, by, it goes 4 to 3.5, 3.5 to 3, by a half. You're changing by a half. Am I going up a half or down a half?
Down.
You're going down. So my common difference here is -1/2 because I'm going down. Do y'all like a fraction or y'all want to do it as a decimal? Which way do y'all like it more? Fraction? Okay. So we go to plug it in. That's our common difference. A1 comes from right here. This is our A1. The x of 1, that represents A1. So this is A1. What does A1 actually equal? 4. A1 equals 4. So you'd plug in your formula. AN would equal, the D is -1/2. N plus A1. What's A1? 4 minus D, which is -1/2. What happens when I simplify here? Remember, the last 2 always simplify. What happens when you have a minus and a negative back to back? Becomes positive. So what is 4 plus a half? Because it was 2 negatives, so they became positive. 4 plus a half is 4.5. Y'all want to do it as a decimal this time? 4 plus a half would be 4.5. That's your formula. Possibly an easier way of doing that when you have a graph is the number at the end would be where it hits the y-axis. If we were to add one more point, where would I put the point if I were to add one more? Would I put it here? Would that be in the right spot on the y-axis? If you were to add a point, would it be right there? No, would it be there? 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 There. There. Yes. What number is that? 4.5. That's where that comes from as well. Okay, and the last one. Let me show you geometric. Here, is this graph discrete or continuous? No, continuous means connected. This one is discrete. It's dotted graph. It's discrete. Since the graph is discrete, it is represented by a sequence. Kiko, you're telling me it's geometric. How do you know it's geometric? What are you seeing? The curve. Since the points follow a curved pattern, it is geometric. Since the curves follow, it is a geometric sequence. Since the curves follow, the points follow a curved pattern, it is a geometric sequence. So finally, find the equation of the geometric. Remember, this is the easy one. It's Gn equals G1 times R to the power of n minus 1. We already know what G1 is, or we could see it. What is the value of G1? Oh, it's hard to see. I'll just tell you. G1 is 0.25. 0.25 is your G1. Your R, it's hard to tell what's going on over here. I'll start right here. This is a value of 1, then it goes to 2, then it goes to 4, then it goes to 8. What's happening every time? I'm using these because it's easier to determine. It was at 1, now it's at 2, then it's at 4, then it's at 8. 1, 2, 4, 8. What's the pattern? Multiplying by how much? To go 1 to 2, 2 to 4, 4 to 8. Multiplying by 2. Our R is 2. N minus 1. And that would be your formula. All right, with that, you've seen it all. You have a DOL, and also you can look and you can see how it was tested on the STAR in the past. All right?